What's going on today, YouTube? Today I'm going to be doing a full tutorial on So-Vits-SVC, which is an AI model that you can train voices on in order to have an AI voice sing any song, basically. So it's not text to speech, rather you feed it in the vocals of a song and it'll just change that vocals into the voice that you train it on. Today, I'm going to be using my own voice. I'm going to be training it with my own voice, getting the audio samples for that, and then running it all the way through to where it's trained. So it's going to be a full end-to-end tutorial today, and I'm going to be using both Google Colab and then a local version of it so we can get both sides. Without further ado, let's go ahead and jump into it. We are going to need to download some things, and before we actually get started in installing anything, I really recommend you install Python, Git, and VS Code. A description link down below will be to a tutorial that I have released on it that you can download everything in less than 5 minutes. So really quickly to get all that installed. But if you have all that, or if you don't care about any of that, it is okay because you'll be able to follow the tutorial without it. But I really highly recommend it if you want to do anything on your own computer to do these type of things. So the first one is going to be voice recorder GitHub, and then the audio splitter GitHub. These are things that I created. So the voice recorder is just a simple Python script that records your own voice so that you can create training samples and training data for the AI model. So what you want to do is click, this is going to be in the description down below, the link to this GitHub, and then you want to go over to this releases area in the bottom right corner, and then you're going to scroll down to voicerecorder.exe. So go ahead and click on that. Then you're going to want to do, go ahead and do save as, and then you're going to want to save it into a folder. So I have a folder called voice recorder, so go ahead and create a folder called voice recorder, and then you can go ahead and save it into there. And then Microsoft Explorer or Microsoft Edge is going to have this warning up here that you'll need to accept in order for you to download it, because exe files can often contain viruses. So that is the warning here. If you trust it, then you trust it. I made this, so I know for me it's safe, but you know, use your own discretion when you're downloading these type of things. So in this case, we're gonna go ahead and do keep, and then we're gonna go ahead and click show more, and then we're gonna click keep anyways. So that is going to allow it to download successfully into the folder. If not, you're going to have an incomplete exe file. The next thing we're going to need to do is download Audio Splitter, which is the exact same thing. Go into releases, scroll down to Audio Splitter. I'm going to click save as up here. I'm going to go into that audio splitter folder, and then I'm going to go ahead and save it. We're going to do the exact same thing here. So when it's done downloading, we're going to click the same 3 dots. We're going to click keep, we're going to click show more, and then we're going to do keep anyway. So now if we scroll into or go into this folder, we have everything we need. So audio splitter and then voice recorder. So what are these two things you just downloaded? Voice recorder is just simply a voice recorder that uses your default microphone to record audio and output it to a folder. So if you have some type of recording software, you can use that instead of this voice recorder I made. That works just fine as well. And then the audio splitter, what this does is it takes long audio files and splits them into 10 seconds or less. This is needed because of the VRAM issues for So-Vits-SVC. And if you don't know what that means, that's okay. We just think about it, we need audio files that are 10 seconds or less in order for this to work. So that's what this does. So with those two installed, we don't need to do much more in order to run the Collab version of So-Vits-SVC. So we're going to go ahead and jump into data curation and how to get some data. And so what I'm going to be reading for my data set are these Harvard sentences, which are supposed to be phonetically balanced. There are a bunch of sentences here, so a lot of variation, and I'm going to do 100 samples. So I think that is going to be 10 lists. And if you're using some other type of data, if you're not training it on your own voice, don't worry, I will go over on how you can cut those audio files up and split them later. But we're going to go ahead and record my voice right now for all 10 of these. So what we're going to want to do is, if you're following along with me, is go into the voice recorders folder, and then you're going to want to open up that voice recorder exe. So your antivirus may block it. You just want to permit it, allow it to go through. And then this little tiny window is going to open with a TK on it. So there are 2 buttons here, start and stop. So here's a quick demonstration. I'm going to click start. Hello, this is a quick demonstration. I click stop, so it stops recording. And then if I go into audio files here, let's go ahead and play the output. Hello, this is a quick demonstration. As you can see there, it just captured it as needed, and that's perfect. And it created its own folder here. So what we're going to do is we're going to run it, and then we're going to say all of the sentences down below, and it's going to give us a nice long audio file that we can split up evenly. So I'm going to go ahead and do that, and we'll be back when I'm finished. Alright, so we just finished reading all 100 samples and we clicked stop recording here. Perfect, that is all we need to do for that. And we have our data. So there are a couple of things that we want to do. If we go ahead and go into that voice recorder folder, you can see that there's an output file here with 6 minutes of audio. So this may or may not be enough audio samples needed for training your data set. So you might need to record yourself saying some more things, maybe in more natural context, but you definitely don't want to go over 10 seconds for the length of those audio files. And that is going to be where the audio splitter comes in handy. So let's head on over into our audio splitter folder, and we're going to go ahead and process the data now. So into audio splitter, we've got the exe here. So let's go ahead and run it. You'll see two options pop up. You'll see audio segmenter and audio splitter. So audio segmenter is going to remove the silence and split all of them into their own WAV file, and the audio splitter is going to instead go through an entire folder, check if any file is 10 seconds or more, and then cut those files into shorter ones. So for this one, we're going to use the audio segmenter, or choice number 1. So we're going to go ahead and click it and then do 1 and then click enter, and the window is going to pop up, and we're going to navigate into voice recorder. That's where our voice audio file was saved, into the audio files folder, and then we're going to go ahead and click output.wav. So we're going to go ahead and click open, and then we're going to name the folder. So this folder we're going to name, let's call it Harvard sentences, because that is what I did. I'm trying not to have any spaces in there, so Harvard sentences, and then it's going to go ahead and find all the silences and split them into each individual WAV file. This might take a little bit of time, so just wait for it to finish, and we'll be back when that's done. Alright, so it finished and it automatically closes, but now you can see inside of the file browser here, I have a folder called Harvard sentences, and if we double click into there, it's going to load all of those new files, and you're going to see a bunch of WAV files, or .wav. So here we go. Here we have all of the samples. We have 100 samples, 99 here because it starts at 0. So we're going to go ahead and take a listen to a couple of them, and so we're going to play the first one. The birch canoe slid on smooth planks. Cool, we'll play the second one. Glue the sheet to the dark blue background. And then the third one. It's easy to tell the depth of a well. And as you can see, the audio files here are each individual file, and they're cut to the appropriate length. So that is going to be the part of the audio splitter that we use right now. The other part of the audio splitter is only needed if your individual WAV files are more than 10 seconds. So say that this audio file was, instead of 2 seconds, it was actually 15 seconds. If I used option 2 when I opened up this executable file, it would split that into two audio files, one that's 10 seconds long and one that's 5 seconds long. And to show you what I mean, I'm going to record a quick dummy audio that is 15 seconds long, and we're going to go ahead and just do the start record here. And so we finished that, and due to it being a little bit different, inside of here we're going to now take this file, which is 20 seconds long. We're going to go ahead and copy, and then we're going to bring it into the audio splitter folder here. We're going to create a new folder called, you can name it whatever you want if you have audio files that are longer than 10 seconds. I'm going to call it test, and I'm going to paste it into here. And one thing to note is that this will delete the original file. So only do this if you want to delete the original file, or make sure you have backups of it. So let's go ahead and run that. We're going to click option. We're going to do option 2, and then we're going to navigate into audio splitter test, and it's going to scan through the entire directory, which is why you don't see any files inside of here. So we're going to select this test folder, select, and it's going to run through it and output 3 files here. That's because it was 20 seconds. So this one is super short here, as you can see, 0 length. But the 2 files here, 10 seconds and 10 seconds right here. And let's go ahead and take a listen real quick. Hello, I'm talking into the mic consistently so that I can create. Okay, and then the second one. The purpose of this is to demonstrate how the audio splitter / segmenter works. And there you go. As you can see, the audio has been split into 3, and you can put as many files into this test folder as you want before you run that audio splitter option on the exe file, on the executable file. So I'm going to delete that because I don't need that, and then I'm going to also delete the original file because I don't need that. Make sure you delete this output.json. We don't need that. We have all 100 samples. We're going to go ahead and head on over into So-Vits-SVC fork. So that is this GitHub repository right here. This is where all of the magic happens, and this is the model that you train the data on. So we're gonna do the Google Colab first. We're gonna go ahead and scroll down into this Google Colab option here. So go ahead and click and open it, and it's going to open a Google Colab window. And before we actually do anything in here, we need to upload the data into our Google Drive. So head on over into your Google Drive. As you can see, I already have one here. You're going to need to create a folder called So-Vits-SVC fork. So go ahead, click new, go ahead, do new folder, and then you're going to name it So-Vits-SVC fork. So once you have that done, navigate into it, and you're not going to actually have any of these. So I'm going to delete all that stuff. That's old stuff. And we're going to create a new folder, and this is going to be the speaker name. So you can name this whatever you want. I'm going to call it me because the model is me, and we're going to create it. And then inside of the speaker name folder, we're going to upload that those sentences. So here I have it. I'm just going to go ahead and drag and drop into here and upload all 100 samples. So we'll go ahead and wait for those to upload. As you can see in the bottom right corner, it's uploading slowly, and that'll finish up. While that's taking place, we're going to head back into Google Colab, and we need to set up a couple of things. So go over into runtime. We're going to go into change runtime type, and make sure you have a GPU. Make sure you have GPU selected here. If you don't have premium, you won't have option to A100s or V100s. Those are much more powerful GPUs if you want to train models faster. The T4 works just fine for the free option. So go ahead, click save, and then we're going to click connect in this top right corner, and it's going to connect us. So we'll wait for that to connect. Alrighty, it's gonna say connected, and if you click this bottom right, or if you click on it, you can see these different charts right here that we'll take a look at later. You want to click this check GPU option, and then you want to click run anyway. As you can see, the important thing is to say that it's a Tesla T4. So now that we have confirmation that we have a GPU running, we want to mount our Google Drive. So what this basically does is give the Colab access to our Google Drive. And if you don't trust So-Vits-SVC fork 4.0, you will probably deny it access, but we need to give it access in order for this to work. So you have to run the cell, and it's going to tell you the same thing right here. It's going to give your Google Drive, it's going to give this notebook access to your Google Drive. So connect to Google Drive and connect. The window's going to pop up here. Click on your email, and then you're going to go ahead, scroll down, and then click allow. All right, and you'll know that it's successfully done if it says mounted at content/drive. And to double check, we're going to click this folder in the left sidebar that says files, and then we want to make sure that it says drive here. So if you click on the drive folder and then you click on my drive, you'll actually see everything that's inside of your your Google Drive. So here we have the SVC fork. If we click on that, we have our speaker name, And then if you click on the speaker name, we have our data samples. So you should be able to see all of the data samples in here if you've uploaded them. So we're going to go ahead and close all of that back down to Drive, and we're all set. So let's go ahead and minimize that and scroll down. Go ahead and install dependencies. This will take a little bit of time, a couple of minutes or so, as it installs all of the Python libraries necessary. All right, and so once that is done, you might see this restart runtime button here. So I don't think we actually need to do this restart runtime option for it to run, but we'll see if we get later on and it doesn't actually run. The next part we do is make dataset directory. So it's going to create a dataset directory. So if we run it here, if you take a look down here, now you have a dataset raw folder. It's got nothing in it. And then to put stuff in there, we're going to have to actually copy the data set. So this is where it's going to access the data inside of our Google Drive. And this data set name is going to be the speaker name that we did. So as you remember, mine is named me. If you don't remember, you can go back into your Google Drive and take a look at the name. So here it is, me. And if you take a look here, you can just see the directory. So my drive, So-Vits-SVC fork, dataset, and dataset name. Here, wait, 1 second. I actually made a quick mistake. So that's why it's always good to read things. You want to create a new folder called dataset in your Google Drive, and then you want to move your samples into that. So the correct file structure should be So-Vits-SVC fork, dataset, then speaker name, and then all of your samples. So now if we take a look back here, we have it correct. So dataset and then dataset name, which is me. So let's run that, and you'll know it's successfully run when you see a green check mark, as you do up here on this cell. As you can see, it finished here. We'll go ahead, double check in files, make sure we have stuff here, and we do. We've got all of the sentences processed and copied. So since everything is on Google's cloud, it actually copies everything super quickly once it's on there. And yeah, so we already have our data set. So we're going to scroll past this cell, and these are the next 4 important cells that, you know, train your model. So the first thing is we're going to do pre-processing of the data. So, and then what we want to do is pre-config here. And so this creates a configuration file that we'll need to configure. So what we want to do now is scroll or go into configs and then go into 44K. And here is our config.json. So when we click on it, a window is actually going to pop up in this right side here where we have all of our training variables that we need to set. This can get a little crazy, and so I'm not going to go too much in depth with it, but some people say that you want to have a total of 25,000 steps. And so a quick way that you can calculate the amount of steps that you're doing. So basically what a step is how long it takes to finish a batch. And so a batch is just the batch size numbers how many samples. So in this case, we're running through 16 samples. So each step is 16 samples long. If you just do the math, you have a formula that comes out to the amount of steps equals your total sample size, so in my case 100, divided by the batch size multiplied by your epochs. So you don't need to really do any math. You can just leave it as is. So that's what we're going to do here. We're going to leave it as 10K. We're going to actually set our log interval at 400. So this is going to save a new model at every 400 steps. You can just use that steps formula to calculate how many times it's going to create a new model, and I'll show you what that model is later. And then we're going to leave learning rate at its regular rate, and we'll just go ahead and leave batch size at 16, which is the default. So you can pretty much leave this all at default and it should be fine. So click Control Save, Control S if you saved anything, and it'll save. And then we can go ahead and re-hide that window and now run the next cells. So we're going to click Copy Configs file, and so it's going to copy over that configuration file into our Google Drive, as that's what it says here. And then this is important. We want to make sure that it's set to creep or crepe. So Crepe actually produces a more human-like, a more natural sounding model. So you want to make sure that you train your model with Crepe. I don't believe you can go back and change it once you've done this. And so the next thing that you might have to do as well is do -N2, and this basically, I believe, tells it how many cores you're running it on or how many threads you're running it on. But we'll go ahead and run it without it just to see how that runs first. So let's run this and see if it goes through pre-Hubert correctly. Let's go ahead and run train and see if it does anything. And so this will be the biggest indicator to see if you did any of the previous steps incorrectly, where you might just have to run the previous cells again. So let's go ahead and see if it runs correctly, and we'll see that. All right, and so I've been sitting and waiting for it to output some more stuff, and it's been going for about 2 minutes and 45 seconds, which means I think something is happening. So we're going to go ahead and click this refresh option here on the tensor board and see if it's doing anything on here. Let's go to scalars, go to hparms, hparams, and so I do actually think it is training. So, but I want to wait for one thing before I leave this to show you that it is in fact training. Okay, so it looks like it actually is training, or else it would have stopped at like a minute. So I actually stopped it and re-executed it to see if it was actually doing anything, and it looks like it's actually training. So we'll go ahead and leave this till it hits the first mark and see how that works. In the meantime, we'll go ahead and jump into another step of the tutorial, which is extracting vocals from audio files and getting those. So let's go ahead and open up a new tab, and we're gonna go ahead and open up go to Ultimate Vocal Remover, which is another GitHub repository that allows you to remove vocals from a audio file. This installation is pretty easy. I'm gonna go ahead and go over the Windows one, and so what we have to do is just click this main download link here, and it's going to ask you up here in the top right what do you want to do with it. So click save as, and we can go ahead and just save it. And so it is a huge file that is going to get downloaded, and we'll go ahead and wait for that. And once that is done, or once it's finished, if you're on Edge, you want to do the same thing: keep, show more, and then keep it. So same process as we did for my EXEs earlier. And then we're gonna go ahead and navigate into where we downloaded it at and run the EXE. So I have this already installed, so I'm not going to run through an entire installation of it, but if you double click into it, a new window is going to pop up. An agreement is going to pop up here. You're going to click next, and then it's going to ask you to do desktop shortcut, and then next, and then it's going to do install. I'm not going to do install because I already have it, so I'm going to go ahead and cancel out of that. Once you have UVR installed, what we're gonna want to do is get some type of song. So here I have Hey There Delilah. This is a music video that I just found on YouTube, and I went ahead and downloaded it. And what I'm gonna do is go ahead and run UVR, and we're gonna go ahead and extract the vocals from it, the instrumentals and vocals from it. Alright, and once it opens up, you're gonna go ahead and click select input. We're gonna navigate into that folder, and then we're gonna go ahead and click it. Like, it doesn't matter if it's an MP4 video, which is what this is. This is an MP4 file. We're gonna go ahead and open it anyways, and then we're going to select the same folder as the output. So we're gonna want to save it as a WAV file, a WAV, and then I just selected MDX net, default batch size, volume compensation auto, and then you want to select this UVR MDX. In this case, we're gonna do both, so we will leave these unselected, and then I'm gonna use GPU for my conversion because I have a good GPU, but you can leave this unchecked if you want it to run on your CPU. You can try either one to see which one is faster for you. So I'm gonna go ahead and click start processing, and it's going to process it, and it's going to run through the process, and done. So here we go. Here we have the vocals of it. Here we have vocals and instrumentals. If I widen this out a little bit, and let's go ahead and listen to the vocals.
Times Square can shine as bright as you. I swear it's true.
And as you can see, it's pretty good. It catches the vocals pretty good. and pretty spot on, and same with the instrumental. Alright, so I just did that, you know, just to sample it. I don't know if it's gonna do one of those copyright things again for my video, so that's why I didn't play too much of it. And yeah, what is important is this vocals file. So we're actually going to rename this to something shorter. So let's go ahead and rename it to vocals.wave, and then we're going to upload this into our Google Drive folder. So head back on over into So-Vits-SVC fork, and we're going to need to create a new folder called audio. And inside of this audio folder, you want to drag and drop that vocals instrumental, that vocal file into. So it's gonna now upload this into your Google Drive. All right, so here, now we're back. So I'm gonna jump back on over into Google Colab, and this is what I wanted to show you. So it should tell, if your model is training, it should tell you and show you your epochs, how fast it's going through. So as you can see, it's finishing for each epoch 9 seconds. So each epoch is taking 9 seconds. So if you do the math here, for 100 epochs, it's going to take 900 seconds. And that comes out to 15 minutes, I believe. And yeah, so this is the longest part that it's going to take. You know, you just have to be patient and wait for it. So as I said, if this process, if this pre-Hubert didn't work and your train is taking like 1 minute or something shorter, then what you want to do is -N2, but it looks like they have fixed it in the more recent version, so we don't need to do that. And so it's going to continue training, and here is your tensor board where you can see, you know, how it's training. But if you don't have any experience with training models, you don't really need to look at any of this. And remember, because I have my log eval set to 400, it's going to do a log evaluation every 400 steps. So that saves your data, and then it's going to evaluate a new model every 800. So if we do 800 divided by 6, it should output a new model. It should do output a new model into this folder once it hits 133. So if we take a look back at here, it's at 101. So I'll just painstakingly sit here until it hits 134 and see if it outputs a new model into my Google Drive. All right, so here we are at 133. And a new window popped up here, which should be indicating that it's saving. So as you can see, nothing is happening here. So it is currently saving the model, and it's going to output it to the Google Drive. So we'll just see what it says after. Alrighty, and as you can see inside of my Google Drive folder, I have a G134 PyTorch file, and it's going to also output a D134 PyTorch file into my Google Drive, but it looks like that's what it's doing right here. So if you want to know how often it outputs models, that's going to be this number right here, this evaluation interval divided by your amount of steps to finish an epoch, and you know, you get your evaluation model. So 133.3. And so it's going to round up to the nearest whole integer, and that's where you get the 134. So we'll go ahead and wait till it finishes and outputs the D, and then starts continuing. And then I'm going to stop it here and then show how an inference works for the model, or basically how you can, you know, use it, quote unquote. It's going to be terrible because it's only one evaluation, but I'm not going to sit here and train it on Google Colab the entire time. Alrighty, and so it has finished outputting the D PyTorch file into the Google Drive, and here we go. So if we go out to the So-Vits-SVC fork folder, we should have one that says datasets, log, and audio. And if you noticed earlier, these are some huge files, so it's going to periodically delete them every 3 models it outputs. And so you might want to keep track of that, because some of there's something called overtraining, but you really shouldn't really care about it too much. That can happen. But if you notice that your finished model is sounding pretty terrible, there are a couple of things that could go wrong. You're maybe either overtraining the model, or you're not having enough good quality audio samples or data samples. And there's a ton of stuff that could be going wrong. I don't have an entire list of what could be, but we're gonna go ahead and stop the training here, and I'm gonna show you how you can now use a finished model, or how you can use your model after the fact, after you're done training it. So we continue scrolling down. Let's say that you come to it another day. You're going to still need to do all of the installation back here. You're going to need to mount your Google Drive, install dependencies, and then you're going to scroll down over to the Inference section, and then we're going to go to use trained model, because that is what we have. So it gives you the instructions here. Put your .wav file into So-Vits-SVC fork audio directory, and as if we take a look here, we do have the folder or the file, and so okay, so it says name is not defined, so let's go ahead and name it to what we have in here. So vocals.wav. Vocal. All right, and it looks like it's inferencing right now, and so the issue with that is there's supposed to be something that looks like this, I believe, on the right hand side here, where you insert your name of the file, but it wasn't there, so we just hard coded it into the code on the left side here, and it should output a file at the end of it. So let's just go ahead and wait for it to finish. All right, and so my inference time took 1 minute for it to finish, or about 2 minutes. And if we go into here, now we have 2 files. All right, vocals.wav and vocals.out. So we're gonna go ahead and play this, and it's I don't know how it's gonna sound after 1 cycle of training, so let's go ahead and run it. Oh, it's what you do to me. Oh, it's what you do to me. All right, and as you can see, it did output it in a terrible rendition of my voice, but that is because, I would say it's accurate sounding of my voice, but the model was trained not long enough. So as you can see, that is a very undertrained model. We only allowed it to go through once. But as you can see, it already has a resemblance of my voice, and that is the power of this repository here. And this is actually me coming back at the end of the video. There might be an issue with this. So it says SVC infer. You might want to add -NA before this and then run it. So if we run this here, let's go ahead and see how that changes the output of the sound. All right, and so now we're running this use trained model. As you can see, there is this parameter that says auto predict frequency 0 false, and we want to make sure that this is off. So it wasn't off on the first time around, and that is why we got that weird sounding audio. So we'll see how much it has improved just simply by adding that -NA to this inference option. But yeah, it finished, and it is right here. So it looks like I can actually play the audio sample here, but we're not going to do that. We're just going to go into our Google Drive and play it from here. So we'll go ahead and run this and see if it made much of a difference on that model that I only trained for literally 1 evaluation interval. Hey there, Delilah, what's it like in New York City? I'm 1,000 miles away, but girl, tonight you look so pretty, as you do. Oh, it's what you do to me. Oh, it's what you do to me. And that was pretty shocking. That is almost as good as the model that I had trained on 25,000 steps, and this was only 800 steps. That's pretty crazy. So that is that. If you want to hear how the other one sounded, just go back a couple of minutes and you can hear how terrible that other one sounded with auto predict on. But that is that. So alright, and so this video is getting pretty long. This is going to be the Google Colab part. I will be releasing a second part where it shows you how you can train it on your own GPU, and that'll be the part 2 for this So-Vits-SVC tutorial. But hopefully you found something insightful for this video. If you liked it, please leave a like. It really helps me out. And leave a comment down below if you need help with anything, or you found anything confusing, or you have any revelations, etc, etc. But see you again in a future video. Look forward to the other one, and I'll see you guys sometime later.